Welcome, good morning, and welcome to e-learning again. Today we'll be concentrating on current electricity and the cause of electric current, that is the potential difference. Beginning with, what is electric current? Electric current is denoted by I and is given as Q by T. When we start learning about any physical quantity, I hope you remember what is physical quantity. All quantities that can be measured. Whenever we talk about physical quantity, we must very soon be also concerned about whether it is scalar or vector, what is its unit, and what kind of a unit it is, that is a small unit or a big unit. What are the other units that we use for it? As far as electric current is concerned, electric current is scalar. Charge of cause is also scalar. Time is also scalar. Unit of current, ampere. See, when I write it in the full form, it begins with a small a, and when I write in abbreviation, I write it as capital A. This is the SI unit. Similarly, as I told you in the previous class, that unit of charge, when I say unit, I obviously mean SI unit. Coulomb, C-O-U-L-O-M-B, Coulomb, C, and time, second. Children, here I have an objection to your writing the abbreviation. SEC is not the unit of time. Please consider that. Small s is the unit of time and it is written as S in abbreviation. And second, if you really want to write the plural, then write the full form, seconds. But never SS, never SS. In abbreviation, it is always S. Okay. So we learnt about the nature and we learnt about the unit. Previous class I also told you Q is quantized and hence it is written as Ne, where E is what? Electronic charge. Where E is called what? Electronic charge. Sometimes the electronic charge E itself is the unit, and other times if I want to talk it in terms of SI unit, it is 1.6 into 10 to the power minus 19 coulomb E. And of course N is what? A number, an integral number. Integral number, that is very important to understand. It can never be a fraction. It is 0, 1, 2, 3 or so on, as I told you in the previous class. So I becomes Ne by T. You got to remember both these formulae. Take for example, if I say that a million electrons flow per nanosecond. What current will it constitute? What current? I write I for current. What current will it constitute? Simple. N million. Million means 10 to the power 6. What will be billion? Billion will be 10 to the power 6 plus 3, 9. Trillion, 6 plus 3 plus 3, that is 10 to the power 9. In English system, it increases by 3, and in the metric system, it increases by 2. Okay, so N is 10 to the power 6. E, of course, 1.6 into 10 to the power minus 19. And T, I said nano. What is nano meaning? 10 to the power minus 9. So this is 10 to the power minus 9 second. Simply put it into the formula. I will be 10 to the power 6 into 1.6 into 10 to the power minus 19 divided by 10 to the power minus 9. This becomes 1.6. This 9 goes up, becomes plus 9. So this is minus 10. This is 6. So minus 10 plus 6, minus 10 plus 6, that becomes 1.6 into 10 to the power minus 4 ampere. As simple as this. Next, a fact to remember: electric current I always flow from, current flows from, a new term I am introducing. I'm sure you know this term. I flows from higher potential to lower potential, higher potential to lower potential. Children, here I'd like to give you some analog. Like for example, I want to tell you liquid, I want to tell you heat, I want to tell you charge. I'm sure you know heat flows from higher temperature to lower temperature. Temperature difference is the cause for heat energy to flow from one point to another point. Similarly, liquid flows from higher potential to higher pressure to lower pressure. If there is no pressure difference, liquid will not flow, wind will not flow. It flows from a higher pressure to a region of lower pressure. Similarly, for charges to flow, for an electric current to exist, it is required that there be a potential difference. So even if we do not know now what is potential difference, at least we can say that the potential difference is the cause for electric current to flow. So take a simple analogy over here. Look it over here. I have two interconnected vessels. I have two interconnected vessels as shown over here. Let us say that the water in the first tube A is at this level and water in B is up to this level. Suppose if we had a cork over here, a stopwatch, something to stop over here, and now we open it. It is easy to understand water will flow from tube A to tube B. The reason? The level of water in tube A is more than level of water in tube B. It is just another fact that water, quantity of water, amount of water, volume of water, mass of water is less in A and more in B. But whatever the thing, the reason why water will flow from A to B is that the level of water in A is more than level of water in B. So water will flow from tube A to tube B. What we understand as water, the same thing we can say as heat. Similarly, we can understand that as charge, and what we understand as level, we can understand as temperature, or we can understand as potential. So for today, just this much. Next video will begin with the concept of potential, and I'll quite simply begin it from this point. Thank you, children.